Hello everybody, welcome to week 4 part 4. C++ stream input output. C++ I/O occurs in streams, which are sequence of bytes. In an input operation, the bytes flow from a device such as a keyboard and network connection to main memory. In output operation, bytes flow from main memory to a device such as printer or a disk drive. An application associates meaning with bytes. The system I/O mechanism should transfer bytes from devices to memory and vice versa, consistently and reliably. Such transfer often involve some mechanical motion, such as the notation of a disk or a tape, or the typing of a keystrokes at a keyboard. The time these transfers take is typically far greater than the time the processor requires to manipulate data internally. So with that being said, I/O operations require careful planning and tuning to ensure optimal performance. C++ provides both low-level and high-level I/O capabilities. Low-level I/O capabilities, such as, for example, unformatted I/O, specify that some number of bytes should be transferred device to memory or memory to device. In such transfers, the individual byte is the item of interest. Such low-level capabilities provide high-speed, high-volume transfer but are not particularly convenient. Programmers generally prefer a higher level view of I/O, for example, formatted I/O, in which bytes are grouped into meaningful units such as integers, floating point numbers, characters, strings, and user-defined types. These type-oriented capabilities are satisfactory for most I/O other than high-volume file processing. So the iStream library headers in C++, the iStream library provides hundreds of I/O capabilities. Several header files contain portions of the library interface, and most C++ programs include the iStream header. In this header, which declares basic services required for all stream I/O operations. The iStream header defines the cin, cout, the cerr or for error, and clog objects, which corresponds to the standard input stream, the standard output stream, and the unbuffered standard error stream and the buffered standard error stream respectively. Both unformatted and formatted I/O services are provided. With the IO manips header declares services useful for performing formatted I/O with so-called parameterized stream manipulators such as setW and setPrecision. The fstream header declares services for file processing. So the IO manip declares services for formatting IOs. The fstream declares services for file processing. The iStream library provides many templates for handling common I/O operations. Class template basic iStream supports stream input declaration or operations. Class template basic OStream supports stream output operations, and class template basic IOStream supports both stream input and stream output operations. Each template has a predefined template specializations that enables char IO. In addition, the iStream library provides a set of type defs that provides aliases for these template specializations. The type-def specifier declares synonyms or aliases for data types. Creating a name using type-def does not create a data type. Type-def creates only a type name that may be used in a program. So the type-def iStream represents a basic iStream that enables char input. The type-def OStream represents a base OStream that enables char output. The type-def iOStream represents a basic iOStream char that enables both char input and output. This UML diagram summarizes the inheritance relationships. So you have templates basic iStream and basic OStream, both derived through single inheritance from base template basic IOs. Template basic iOStream derives through multiple inheritance from templates basic iStream and basic OStream. Formatted and unformatted output capabilities are provided by the OStream. So the output operator has been overloaded to output a char, star, and null terminated C style string. To output the address, you can cast the char star to a void star. This can be done to any pointer variable. Program you see here demonstrates printing a char star variable in both string and address formats. The address prints as a hexadecimal base 16 number. In general, the way addresses print is implementation dependent. Character output using member function put. What do we use the put member function for? We can use the put member function to output characters. For example, the statement cout.put a displays a single character a. Put calls to put may be cascaded as in the statement cout.put/n. Without outputs the letter a followed by a new line character, which outputs the letter a followed by a new line character. As with the output operator, the preceding statement executes in this manner because the dot operator associates from the left to right, and the put member function returns a reference to the OStream object cout that received the put call. So the put functions also may be called with a numeric expression that represents an ASCII value, as in the following statement cout.put65. This is also puts out the a character. Stream input, formatted and unformatted input capabilities are provided by the iStream. So the stream extraction operator normally skips white space characters such as blanks, tabs, and new lines in the input stream. Later we'll see how to change this behavior. So after each input, the stream extraction operator returns a reference to the stream object that received the extraction message. For example, cn and expression cn grade. If that reference is used as a condition, the stream's overloaded void star cast operator function is implicitly invoked to convert the reference into a non-null pointer value, or the null pointer based on the success or failure, respectively, of the last input operation. A non-null pointer converts to the bool value true to indicate success, and the null pointer converts to the boolean value false to indicate failure. When an attempt is made to read past the end of a stream, the stream's overloaded void star cast operator returns the null pointer to indicate end of file. So each stream object contains a set of state bits used to control the stream state, for example, formatting or setting errors states. These bits are used by the stream's overloaded void cast operator to determine whether to return a non-null pointer or the null pointer. Stream extraction causes the stream fail bit to set if data of the wrong type is input and causes the stream's bad bit to be set if the operation fails. Tying an output stream to an input stream, how do you do that? Interactive application generally involves an I stream for input and an O stream for output, as we established so far. So when prompting message appears on a screen, the user responds by entering the appropriate data. Obviously, the prompt needs to appear before the input operation proceeds. With output buffering, outputs appear only when the buffer fills. When output are flushed explicitly by the program or automatically by the end of the program, at the end of the program. C++ provides member function tied to synchronize, for example, tie together, the operation of an I stream and an O stream to ensure that outputs appear before their subsequent inputs. So the call cn tie %cout tie cout in an O stream to cn and I stream.